Welcome to The Explainer. Today, we're diving into a genuinely fascinating thought experiment. But listen, we're not talking about some sci-fi Hollywood apocalypse here. No, we're looking at a strict scientific breakdown of nature's relentless resilience, based entirely on the hard laws of thermodynamics, chemistry, and biology. We're going to map out the exact timeline of how the Earth reclaims itself. Okay, let's dive into this. Imagine a scenario where, in a single instant, every human being just vanishes. Gone. What exactly happens to this massive world we've built? Well, the immediate aftermath isn't characterized by massive explosions or chaotic destruction, but by something else entirely.
Think about it. For hundreds of thousands of years, our planet has just been vibrating, right? The constant drone of internal combustion engines, the hum of power lines, the clatter of heavy machinery. But the second we vanish, all of that anthropogenic noise ceases completely. The atmosphere is literally cleared of our acoustic turbulence, returning the Earth to a state of immediate primordial quiet. It would be eerily peaceful.
Part 1. The sudden silence and the first week. So to really understand this, we have to remember that our cities and infrastructure, they're basically temporary states of low entropy. They are completely unnatural systems that only exist because we constantly pump exhausting amounts of human energy into them. Once we're out of the picture, that energy grid fractures within hours. Without humans balancing the supply and demand, automated safety valves at power plants are going to start to shriek as they furiously vent excess pressure. By day 2, just 48 hours in, without electric pumps running, coastal subway systems like York's flood completely. They're totally submerged. By day 7, the backup diesel generators at nuclear plants deplete their fuel. And tragically, in this exact same window, millions of trapped domestic pets and enclosed livestock perish without us there to provide food and water. Let's move to part 2 and see how this builds month 1 to year 1. Nature reclaims. The first year without us sees this dramatic, frankly violent realignment of Earth's fauna and its atmosphere. Our domesticated animals face a brutal and immediate evolutionary filter. What that means is highly dependent on toy breeds you might have sitting on your couch right now, like pugs or chihuahuas. Unfortunately, they disappear within weeks. But the larger breeds, your German shepherds, your mastiffs, they quickly revert to pack-hunting behaviors just to survive. Meanwhile, unchecked wildfires, sparked by totally natural dry lightning strikes, start raging through all those overgrown suburbs. Fire actually becomes the primary new architect of the landscape. Now, if you look up, the skies are undergoing a spectacular transformation. Within just a few months, those short-lived industrial pollutants and that persistent layer of smog over our major cities, it dissipates entirely. We're talking pristine, crystal-clear skies. But high above that, without ground stations constantly giving them little orbital boosts, our communication and military satellites slowly succumb to atmospheric drag. They start streaking across the night sky, literally vaporizing in the mesosphere, like shooting stars. Moving on to part 3, year 10 to 500, the fall of infrastructure. Over the next few centuries, the boundary between our artificial world and the natural world completely blurs, and then it just vanishes altogether. And this brilliantly illustrates how it happens. Look at our roads. It's a relentless process of physical weathering. First, rainwater seeps into microscopic fissures in the asphalt. Then, in winter, freeze-thaw cycles brutally expand those cracks. Windblown soil settles in, and boom, pioneer seeds like the highly invasive tree of heaven germinate. And those little roots, they exert immense hydraulic pressure, literally tearing apart our seemingly permanent roads from the inside out. But it's not all just green plants making a comeback. Over at our abandoned industrial sites, rusting steel kinks are spilling toxic acids and heavy metals, creating these nasty, localized dead zones. But nature has a biological counterattack ready to go. Specialized oil-eating bacteria, like Alcanovorax barcamensis, rapidly proliferate in those petroleum spills. They go to work, slowly breaking down complex hydrocarbons into entirely harmless organic molecules. It's wild to think about. Now, our nuclear legacy is a bit more complex. Without active cooling systems, the spent nuclear fuel pools eventually boil away. This causes fires and releases short-lived radioactive isotopes, like cesium-137. But here is the ultimate twist of irony. Despite the localized radiation, the absolute absence of human hunting and habitat destruction turns these exclusion zones into accidental wildlife sanctuaries. Megafauna, we're talking wolves, wild boars, and bears, end up absolutely thriving right in the ruins of the atomic age.
So the crucial point is, think about the concrete you walk or drive on every single day. Our most foundational building material actually possesses an inherent, built-in, self-destructive flaw. Carbon dioxide dissolved in rainwater eventually penetrates the porous concrete, neutralizing its natural alkalinity. And once that acidic matter reaches the internal steel rebar, it rusts. And because rusting steel expands up to 6 times its original volume, it literally forces the concrete to crack and spall. This single chemical reaction is what brings down elevated highways and massive skyscrapers all across the globe. Interestingly, unreinforced masonry actually fares much better. While your unpainted steel suspension bridges will snap within just a few centuries due to salt spray oxidation, massive solid structures, think the Egyptian pyramids or the Hoover Dam, they survive for millennia. However, even something as mighty as the Hoover Dam is ultimately defeated by shifting geology. What happens is its unmanaged reservoir simply fills up with silt, and the Colorado River just shrugs and carves an entirely new channel right around it. Part 4. Year 1000 to 10,000. The carbon balance. All right, zooming way out now. By this point, the topography of former megacities like Paris, New York, or Shanghai, they're basically just artificial hills completely covered in thick forests and rich topsoil. And it takes this exact, massive time frame for the global climate to finally stabilize. Short-lived methane, that oxidizes within about 12 years. Over the first millennium, the oceans absorb roughly 70% of the excess carbon dioxide, though they suffer severe acidification in the process. But by year 10,000, natural geological processes, like the slow weathering of silicate rocks, successfully sequester all that remaining carbon, returning atmospheric CO2 right back to pre-industrial levels. Part 5. 10 million years. The Anthropocene geological anomaly. Okay, I want you to imagine an alien geologist arriving on Earth 10 million years from now. At first glance, they'd see a seemingly untouched, thriving, pristine blue marble. But if they dug down into the sedimentary rock, they wouldn't find our grand cities. Instead, they would find a bizarre secret hidden beneath the surface. Now, what's really interesting about this slide is this Anthropocene boundary layer. It's an unmistakable chemical signature tightly packed with plastic glomerates, which is literally microplastics fused together with volcanic basalt. They'd find technofossils, like titanium aerospace parts or synthetic gems. They'd see chemical anomalies, like sudden global spikes in lead, and even a radioactive clock of long-lived isotopes, like plutonium-239 that has slowly decayed into uranium-235. And out of all our magnificent art, our towering architecture, our incredible achievements, do you know what our defining fossil footprint is actually going to be? The globally slaughtered domestic broiler chicken. Yep. Billions of their anatomically altered bones, deposited in highly concentrated landfills worldwide, will serve as our era's primary index fossil, permanently signaling our brief, intense dominance over the Earth. Looking back across this vast stretch of time, the sheer scale of Earth's reclamation is genuinely humbling. From flooding those subways in week 1 all the way to the formation of that Anthropocene rock layer millions of years later, nature methodically, patiently erases virtually every physical structure we've ever built on this planet. Part 6. The Outward Echo, Our Cosmic Legacy. But you see, our story doesn't actually end on Earth, because humanity's longest-lasting physical legacy is actually sitting up on the moon. Contrast the relentless weathering, the tectonic subduction, and the hyperactive biosphere of our home planet with the geologically dead vacuum up there. On the lunar surface, there is no wind, there's no rain, there's no rust. The footprints left by the Apollo astronauts, the descent stages of the lunar landers, and the American flags, which are bleached completely white by solar UV radiation by now, they will sit entirely undisturbed by anything but microscopic meteorites for well over 1 billion years. And pushing even further out, deep into the interstellar void, are our 5 robotic emissaries. Long after Earth has completely reabsorbed the concrete of Tokyo and New York, and long after the radioactive signature of the atomic age has faded to nothing, Voyager 1 and 2, Pioneer 10 and 11, and New Horizons will still be intact. Carrying those golden records inscribed with our music, our anatomy, and the exact coordinates of our home planet, they will float silently through the cold, empty spaces between the stars. It leaves us with this incredible, provocative thought. Everything we built on Earth is temporary, right? Destined to be reclaimed by the very natural forces we tried so hard to hold back. But out there, in the quiet dark of the cosmos, our memory endures. So, what is our ultimate legacy as a species? Perhaps it's simply that, for a brief, shining geological second, we existed, we learned, and we looked up at the stars and wondered.
Please like and subscribe.